So as you know, AI agents are in the news everywhere. You've probably heard about them. And you're thinking what an AI agent is. And so the idea here with this snippet is to give you fairly quickly an overview of what an AI agent is and also how it's different from a large language model like the GPT that powers ChatGPT, for example. So let's quickly overview what an AI agent is, right? So an AI agent is basically software, right? And sometimes it's combined with hardware depending on the task it's kind of operating. And what an agent does is it can plan and execute step by step to achieve a goal that's assigned. Now, what makes it interesting is the fact that agents are supposed to be able to take intelligent decisions to try and achieve these goals, right, in an autonomous manner. So you're trying to ensure that the agent does not each time have to be prompted by a human being in the loop, right? Rather, it can semi-autonomously or autonomously perform, the task it's been assigned and find ways to perform that task in a step-by-step manner. And what it can do to try and achieve this task is interact with its environment, right? It could be purely software, in which case it's interacting with other tools, with the net and so on, or it could be something more interesting like a robot, right? Where it's now interacting with the environment. And based on the feedback it's getting, then dynamically kind of find ways to find a solution. Sounds very complicated, but actually you're already familiar, for example, with an AI agent. So self-driving car, and you've been hearing about self-driving cars for a long time now. They're an example of an AI agent, right? So you take a self-driving car and let's just assume we're at the point where they're completely autonomous. You tell it that you want to go to work, right? So the goal it's been set is to get you from home to work, right? Now, what does the autonomous car do? First, it interacts with the navigation system. So the agent, think of it as the agent. And for now, let's just think of it as one agent, right? No reason not to do that. We say what it does first is once you get into your car and you're strapped in and it's switched on the AC for you, what it does is interact with the navigation system, right? And once it opens up maps, it finds the quickest possible route from your home to your workplace, right? Taking into account all the current traffic conditions. What does it do then? Well, it controls the accelerator, the brake, the steering, and so on, the indicators and so on to try and get you onto the road. And once you're on the road, what does it do? Well, it uses, the sensors it's been equipped with. So cameras, LiDAR, and then those are then processed by deep learning vision models, convolutional nets, for example. And it uses that to detect pedestrians, to detect other cars, to detect the lane it needs to drive in, to obey traffic signals. And it gets you from your house safely to your office. And maybe what it could also do is switch on the AC if you ask it to. So it's conversing with you now. Or it could turn off the music if you are, not in the mood and want to go to sleep. So now an autonomous car is actually not one agent, it is a combination of agents performing different tasks. But it's a good example of what an agent would be, right? Obviously, in fact, a very complicated example. Now, the different types of AI agents. So a simple reflex agent, for example, is something that's very simple that just responds to a sensory input. So there's a sensor, it gets an input and just responds to it. So a thermostat, right, just sees the temperature and responds accordingly. And so, as the name suggests, just a reflex action, right? It's just to something. It does not have an inbuilt model or a memory or anything like that, and it's not definitely not learning. Then what you could have is a reflex agent with a model. So it's taking in the sensory input, but now it has an internal model that tells it what to do, right? But then what you could have, the next evolution of that is a model that obviously takes in the inputs, has models, but also has a goal, and it's trying to find ways, given its restrictions, to achieve that goal. So it becomes a goal-based agent. Now what you can do is make it more interesting by adding what is called a utility function, right? Which are ways for it to evaluate, its goals and its actions and try and find a way to optimize that goal or action. So, I want to get from A to B, but I want to minimize how much fuel I'm burning and I want to keep the passenger safe, is an example, right? And then, of course, you have what are even more interesting, which are learning agents. So these are agents that, as they get more data, are exposed to its environment can get better. So a recommendation system sees more of your, sees more of what you're doing and accordingly understands your taste and recommends relevant content to you, right? It could be a driving system that as it drives more and more on the road, gets better at understanding traffic conditions. Could be an AI agent that is trained to play chess, and as it plays chess, it understands more the game, it understands the game more, understands the moves better, and is able to play better. And what you'd see in an example we looked at, which was a self-driving car, is a combination or a hybrid agent which combines multiple agents depending on the tasks it wants to solve. So it leverages the power of all of these agents. So it's a simple outline of the different types of agents, and you see that an agent need not be very complicated. It could be something as simple. What you hear about today are more complex agents that can perform complicated tasks, because that's the goal, right? To kind of bring in agents that can do fairly complicated things. Now, it's an age where language models, ChatGPT, um, you know, is something, Gemini, Google's Gemini. These are all models, Llama. We've been hearing about that a lot. So, what's the difference between that and an agent, right? Well, those are language models, right? Or apps built on language models, like GPT, for example. So, a language model or a large language model is a machine learning AI model, typically a neural network, right, with number of layers, so lots of parameters, um, that is trained to understand language. It's trained on a lot of data, a lot of text, a lot of information, and it's trained so that you give it a prompt or an input and it generates an output according to that. So it's just a model like any other math model or machine learning model, takes in an input that the user provides and returns an output. Now, it by itself is not supposed to act autonomously, right? It's just you tell it, write me an email and give it a subject that goes in as the prompt, and the model computes. So the input goes into the neural network and the neural network generates the output. It's trained to predict the next set of words, the next set of sentences, and it returns an output to you. And these models are trained on terabytes and terabytes of data on the internet, Wikipedia, a lot of other data. Of course, it could be an image model. It doesn't have to be an LLM, but we're looking at LLM. We're saying image models are trained on image data, right? Now, an LLM, depending on the agentic system you're trying to build, could form the core of it, right? But it's not an agent by itself. However, what LLMs could do, what agents could do, is use the LLM, right? So it could be the core of the LLM, a core of the agent that then communicates with you, right? So the agent uses the language model as its core or as a tool to interact with its environment, to interact with people, and achieve its goal, right? And so I just used the word tool. So what are tools when it comes to an agentic system? Well, so the LLM, as I said, could be considered, depending on the application, the core, right, of the agentic system, right? On the other hand, a tool is something that is used by the agent to do a task, right? So it's to perform an action that's external. So for example, ChatGPT, for example, has introduced the search feature, right? So what it's doing is you're giving it a prompt, and so technically it could qualify as an agent because it's going and searching the web and then coming back and giving you those responses. So it's not just the language model that's acting. It's going and calling a tool which is searching the web and getting the responses. So a retrieval augmented generation or a RAG system, and it's giving you the response. So you could search the web, you could call other APIs, you could say, I want a document from Google Drive to be pulled and I want it to be analyzed. You could link to other databases. You could then take the data and run analytics to it. So an agentic system uses the language model, could use it as a tool. Maybe if it's an agent to do something else, it could use the language model as a tool, could have other tools as well that allow the agentic system to achieve its goal, right? And interact with the environment. So let's look at a simple example, right? We've looked at a self-driving car, which is a very complicated example. But let's look at a fairly simple example. Let's look at an agent that's just designed and trained to manage your email. What does it do? It monitors your inbox. So you've given it access to your inbox. Hopefully, it's not monitoring on its own. And what does it do? It notifies you if there's an important email, and also passes those emails and gives you the summary. So you don't have to read every email. It is designed or set up to know what emails are important. And once it knows what emails are important, it gives you the summaries. How does it do that? It uses language models, right? So it leverages the language models to read through your emails, summarize it, and communicate that summary to you. What you could also have the agentic system do, if it's a smart email agent, is you could have it kind of point to it key threads and ask it to keep the conversation going. So say, it's an email with a supplier and it's an official email and you want to keep conversing with that supplier. You could have the system kind of send the supplier some information, get a response, place an order, for example. Or it could be emails that are customer support, and the agentic system could read through the customer support, give you a list of to-dos, right, that you implement, but then respond back to the customers, right? And so it's an example of what an email management agent could do. Now, you could have more interesting agents like a customer support agent that could take the customer's feedback, check his order. If it's a digital kind of thing that needs to be fixed, fix the thing, send the request to be fixed digitally. If the customer wants a refund, it could check if the customer's product is defective and the customer's maybe sent an invoice and a photo of the product. And if so, reimburse the customer. So different examples of what the agent is and how it uses an LLM, or it could use any other machine learning model. It could maybe be an image model centric thing, but it's using inputs from images to then perform a task. But hopefully you're starting to get the basic idea of what an agent can do. Now you're probably hearing the term multimodal agents. So how is that different from a single, simpler agent? The answer is very simple. It isn't very complicated. Say an email agent is just reading text, so it's single modal. It just understands text. But you could have an agent which takes in text and understands that because it's got a language model. Could also have image models built in that then can process images, right? So now you're reading text and images. You could say something that's taking in, audio. So you could have, say, text and audio. So, modern assistants, for example, can take in text and audio, right? And so you can talk to it and it'll give you a response, but you can also give it text prompts and it'll respond to that. You could have systems that take in sensors. So this is LiDAR from a self-driving car. This is an example of a chip that's a sensor. So a self-driving car would use images, it could use the LiDAR, it could also use audio to communicate with you, right? And so if it has multiple modes of communication, both data coming in and going out, it becomes a multimodal agent. So hopefully this is starting to give you an outline of what AI agents are. It's not very complicated. They're made to sound very complicated sometimes, but they're basically systems that are software that are trained or that are set up to perform tasks in their own way. So they're allowed to kind of use machine learning models, use language models to communicate and on their own perform tasks. So search the web, do a financial transaction, be very careful when you do that. Place an order, write an email, and send the email. Instead of, say, just a typical language model, which you say, write an email, it writes the email for you, right? But then you have to say, okay, I'm going to click send, or I'm going to copy paste this to my email. Whereas the agent would have access to the email, would have access to the language model, and it would, based on what you've told, it might read your previous email, would access the language model, could access whatever information you needed to access, draft a response, and maybe without your approval, if it's set up to do so, send the response, right? And keep that communication going. So that's the difference between a language model or a machine learning model and what agents are. Now, it sounds like, agents are going to take over the world right away. But there are a lot of challenges associated with agents as well. The first thing is they require large computational resources. So even running language models and large language models successfully requires large resources. Adding to that, agents and how they function computationally, it's quite complicated, which also means it's going to be a large cost of development. You also need the systems to train these models. You need the engineers to train it. You need tons and tons of high quality data. So it is quite expensive. And then the thing is, what if these agents struggle with complex tasks? You get it to manage your bank account, you ask it to process insurance claims, you ask it to do medical related tasks. You're kind of trusting the agent to do complicated things that could have real life consequences, right? Could hit somebody's personal finances badly, could cause a health issue. And so, you need to make sure these agents can function and perform these tasks exceptionally accurately and reliably before you can actually adopt them to do complicated things, right? And then, of course, another problem is a lot of deep learning models, are very opaque, right? You're not sure why the model is giving you a response. And so now if an agent is using a deep learning model or multiple deep learning models and is powered by them, sometimes you're not sure why an action has been taken which can be problematic because it could be right or wrong. You would not know why it's right or wrong, and so you cannot predict how it's going to do something in the future. So again, consistency and reliability become a challenge. That being said, it's an interesting phase in the age of AI, and hopefully with this kind of snippet, you've understood and or had got a broad overview of what an AI agent is and what it can do. So, if you've enjoyed this, see you on the next.